In this video, we're going to verify a trigonometric identity by multiplying by a conjugate. So the idea is this. The idea is that if we have something of the form a plus b, the conjugate of that is going to be a and b, but instead of a plus, we'll put a minus. And this gives us a difference of two squares pattern. So when we multiply it all out, we get an a squared minus b squared. If we started off with something that was a minus b, its conjugate would be a plus b, and we would still have a difference of two squares pattern, and we would get a squared minus b squared when we multiplied this all out. So we're going to use this idea in this particular problem. So to verify this identity, I'm going to start with the right hand side. I'm going to take 1 minus the sine of x over 1 plus the sine of x. And I'm going to go ahead then and multiply the numerator and denominator by the conjugate of the denominator. So I want to remember these are grouped, numerators grouped, denominators grouped, and then the conjugate of the denominator is 1 minus the sine of x. So we change the operator plus to minus. And this is going to be useful because in the denominator we're going to wind up getting an a squared minus b squared form. So it's going to be 1 squared minus sine squared, or 1 minus sine squared, which will be a Pythagorean identity, and it will allow us to simplify things. So multiply everything out, we get 1 times 1 is 1. We're going to get minus sine x times 1 2 times. So we get 2 minus sine x's, 2 of the middle terms, and we get minus sine times minus sine is plus sine squared of x. And the denominator, we have the difference of squares form, so we're going to wind up with a 1 from 1 times 1. The middle stuff will cancel, and we'll get plus sine x minus sine x is minus sine squared of x. And then we want to recognize that this right here is just the Pythagorean identity showing up again. Cosine squared plus sine squared is 1. So if we subtract sine squared from both sides, we get 1 minus sine squared is equaling the cosine squared on the left. So we can replace the denominator with cosine squared. So we get 1 minus 2 sine x in the numerator plus sine squared x in the denominator. And we're going to be able to put a cosine squared in the denominator, but instead of just dumping it into the denominator like this, I'm looking up here and seeing that I need to have a denominator of 1 ultimately. So I'm going to take my cosine squared, I'm going to break this up into its individual pieces with the common denominator cosine squared of x. And this is to try to rewrite it in such a way that all of the denominators are a 1, which is what we ultimately need. Whoops, and this should be a squared, and u should be squared. And then we want to simplify these pieces. So 1 over the cosine squared is going to be secant squared because cosine and secant are reciprocals. So 1 over cosine squared is the secant squared of x. And we get minus 2 times, and we have sine x over cosine squared of x. We want to recognize sine x over cosine squared of x is really just this. So it's really, if we break the cosines up into the two pieces, it's really sine over cosine times 1 over cosine of x for that cosine squared in the denominator. So we have a tangent and a secant sitting here. So sine over one of the cosines is a tangent function, and then we have 1 over a remaining cosine, which is a secant function, plus sine over cosine is tangent, so sine squared over cosine squared is tangent squared of x. And then what I want to recognize is the form that I have here. Here I have a y squared form. I have a y being squared minus 2. So if secant is a y, I'm going to let tangent play the role of an x. So this is a y squared minus 2xy plus x squared form. Something squared minus 2 times that same thing times another thing. Hey, the other thing's being squared at the end. It's a y squared minus 2xy plus x squared form, which means it factors as a y minus x times y minus x type of a guy. Y times y is y squared, minus xy 2 times, minus x times minus x is plus x squared, or just y minus x quantity squared. That's the form that we have, where secant is playing the role of the y and tangent is playing the role of the x. So I really have a secant of x minus a tangent of x being squared, which is what we needed to show.